Okay, so for perfect squares, hopefully you have most of your perfect squares memorized up to 144. But there are ways to do them if you don't have those memorized. Of course, we can always use our calculator as well. But I just want to remind you that when you're doing these perfect squares, the reason they are the way they are. So hopefully you look at square root of 25, you immediately think 5, and the reason why is because 5 squared is 25. Notice it's just that number that's being squared that we want. We don't have to say that there were two of them. We know there were two of them because you're looking at the square root. So the same thing with 144. That would be 12. And again, that is because 12 squared is equal to 144. Like I said, hopefully most of you guys have up to 144 memorized, but you can definitely use your calculator if you need to on any of these perfect squares. So the square root of 64 is 8, and again, this is because 8 squared is 64. So when they're perfect squares, they're not too bad to work with because they do have that perfect number. That squared is what's underneath our radical, which actually we call this number right here underneath the radical a radicand. Now, when they're not perfect, they're a little bit more complicated. And what we're going to do that is we're actually going to use factor trees. And remember, when you're doing a factor tree, it doesn't matter how you start your factor tree. As long as you take it to prime numbers, they will always come out the exact same. So what we're going to be looking for in these factor trees is we're actually going to be looking for pairs of numbers. So every time we see a pair of numbers, we actually get to take one of them out. So for example, if we're doing 12, we can break 12 down to 3 times 4. 3 is a prime number, so I work over here to 4 and I break him down to 2 times 2. Now, one of the things I want you guys doing is I want you to cross out that 4 because you're not going to talk about that 4 ever again. You're only going to talk about what we call the terminating ends, and that is 3, 2, and 2. You notice that right here you have a pair of 2's. One of those 2's is going to come outside of the radical. He's going to be here. The other 2, he's part of this guy, because remember, it's the 2 squared that you're looking for, so you're just wanting to know about the 2. And then you're going to put your square root back, and you're going to say, well, wait a minute, I still have this 3 that I haven't talked about because he doesn't have a partner. So he is going to stay inside the radical. So the square root of 12 is the same thing as 2 square roots of 3. So let's try the next one. We've got the square root of 130. So again, I'm going to break this apart using my factor tree. Guys, whenever I do a factor tree, if it ends in a 0 is my favorite thing because I can always do the 13 times 10. So you just take whatever's in front of it, that becomes your first factor, and then 10 becomes your second. Now 13 is a prime number, so we can't do anything to it. And 10 is 5 times 2. Now you notice there aren't any pairs in that thing because again, I'm not going to look at the 10. I'm only looking at 13, 5, and 2. So really 130, there's nothing we can do to simplify that. So it is going to stay the square root of 130. Okay, the same thing actually happens to the next one. So if we're looking at this guy, this is going to be 3 times 10. Again, 10 is 5 times 2, so I'm not going to mess with that 10. I'm just looking at those terminating ends, and I don't have any partners in that. So this is also going just to stay the square root of 30. Let me give you one more example where it actually does work out and we can pull a number out. So let's say we had the square root of 75. Okay, so again, we wanted to break this apart. So 75 is definitely divisible by 5 since it ends in a 5. And 75 divided by 5 would actually give you 15. Then we could break 15 apart because 15 is 5 times 3. Again, I'm not going to look at the 15. I'm only looking at the 5, and the 3. So notice that you do indeed have a pair of 5. So you're going to pull out, again, only one. So that's going to be a 5. Left underneath your radical is a 3, so this would be a 3. And you would end up saying that the square root of 75 is the same thing as 5 square roots of 3.